Hello and welcome to another World Cement Spotlight interview. Today I'm joined by Mr. Hans Conrads, owner and CEO of PROMECON. In addition to an electrical engineering and signal processing degree from the University of Aachen, Hans has over 25 years of experience in the power industry as an entrepreneur and inventor of novel measurement systems for optimizing combustion in large steam generators. He also has multiple international patents and innovation awards to his name. The subject of today's Spotlight session is the article that Hans wrote for a recent issue of World Cement. Entitled Getting the Right Balance, this article outlines how new gas measurement technologies can enable a more consistent and accurate gas flow balance in the clinker cooler, thus leading to a more efficient and sustainable production process. Thank you, Hans, for taking the time to join me here today. We've got some interesting topics to go through, and I'm sure our audience will be excited to hear your thoughts.
Well, thank you very much for having me on.
Excellent. Okay, so let's begin. To start things off, for those who may not know, can you tell us a bit more about PROMECON, your expertise, the sectors you cover, etc.?
Our company is actually focusing on a thermal process measurement, and there are quite a few big areas where we are active in. One would be power generation, of course. There's a very big thermal process that would include coal-fired, biomass-fired, oil-fired, large steam generators. Another area would be the steel industry, where you have a lot of thermal energy going in and out. Then the big sector which we're going to talk about today, which is cement. So we actually have been going through quite a few sectors and areas. Another big one would be the paper industry, glass industry. So our company is looking into sectors where you have a lot of energy and a lot of money turning around in a big process, and we try to optimize these processes by better flow measurement. So we're an instrumentation and measurement company looking at the process of our clients and trying to optimize these processes.
So focusing on the cement sector specifically now, can you tell me about the range of systems that PROMECON produces and what applications they would have in a cement plant?
Yes, there are actually two flow properties that we are measuring. The first one is gas flow. So basically a single phase flow measurement of all hot gas streams in a cement plant, which can be raw mill off gas, clinker cooler off gas, tertiary air, kiln preheater gas, all sorts of gas flows. And this is a very wide area in a cement plant because you have numerous gas flows which are all hard to measure. The second thing that we are measuring is two-phase flows, which means solid materials suspended in gas. This could be coal, this could be raw meal, this could be fluff or secondary fuels that are used in cement processes. And those actually are then both sides of the equation. One is the gas flow or even the air flow, and the other one is the fuel flow, which is important to create the thermal process. All these things are very hard to measure, and there are numerous locations where we can measure this in order to optimize each part of the process.
Okay, thank you. For those who haven't yet had the chance to read your article, can you explain how systems like the Macon Air compact system operate? What makes them so effective at measuring gas flow?
Yes, I'll be happy to do that. We have to first dive into the question of how do you measure gas flow? What is gas flow? And the most traditional way to measure gas flow is no direct measurement, but an indirect measurement by measuring a pressure drop. So everybody knows that if you're measuring a gas flow, you have some sort of orifice or venturi or some sort of narrow section of duct in which you create a differential pressure between the wide section and the small section. And that pressure is then a measure of the gas flow that you have, right? So basically what you're doing is you're measuring a pressure. Now for this, you need to have pressure tabs in order to measure the pressure differential between the 2 points. Now, if you have clean gas flow, this is rather simple. In a cement plant, we all know there is no clean gas flow. There is dust, there's all sorts of obstacles. And pressure tabs usually are clogging up in a very short time. I've not seen any cement plant measuring with a delta P measurement without intensive maintenance. So most of the gas flows in the cement plant are not measured at all. Yeah, people are just blind to that. So what do? We have invented a new measurement method with two sensors that we put into the gas flow, and those two sensors, they measure the electrification of the dust particles that are carried through with the gas. And we're measuring this electrification in form of a small electrical current that's on the antenna. And now what we do is we're measuring these in two spots, antenna 1, antenna 2. And we see a typical time pattern of this electrical signal on both antennas. And now the real tricky part is we compare these patterns, what we call cross correlation, and our electronic circuitry gives us the time of flight of the particles by calculating the time shift between the two patterns. So what we are basically measuring is a time shift between 2 points. I think this is the most direct way to measure velocity anyway. Velocity is distance over time. So we have a distance of the two sensors, we measure the time shift of the two patterns, and by that we measure velocity. So that's what we measure. We measure direct velocity, and the big advantage of this measurement is it is a digital measurement. So it is not an analog value that has to be converted by K factors. It's a digital direct measurement. Secondly, it's absolutely drift-free because the only variable that we're measuring is time. Now, how accurate can you measure time? Time measurement is the most accurate measurement that mankind ever invented. So we're bringing this digital time of flight measurement into the cement industry, and in a nutshell, the measurement is fairly plug and play, and once it's running, the next time you look at it is 10 years later. There's nothing you have to do with it. It just keeps on going and going. And for many cement plant operators, that is the most key thing why our measurement is so different from the other ones.
Okay, thank you. Now, your article focused on how these kinds of measuring systems could optimize clinker cooler operation. Can you discuss a recent case study where this was done?
Yes, we have actually optimized quite a few processes in cement plants. And part of it is clinker cooler. Other processes would be raw mill operation, fan operation, lowering fan power consumption. By the way, a big problem in cement. You have a lot of fans on the clinker cooler. You have a lot of fans on the raw mill. Nearly half of the energy that you use on the cement plant to grind and things is just fan energy. Blowing the gas to where it goes is the biggest power consumption factor, electrical power consumption factor in a cement plant. So we have actually done quite a few studies on that. And there are studies available from Holcim and others on raw mill. On the clinker cooler itself, the process is slightly different. Many plants use what they call optimizers, which are usually provided by the plant construction companies, such as FL Smith or Polysius. They have all their own optimizer system. And what many plants really appreciate is to take our gas flow from the clinker cooler into their optimizer system in order then to optimize the critical points of the clinker cooler. For example, the neutral point in the middle, or the off gas to one side, or the tertiary air to the other side, or the calculation of the secondary air into the kiln. So I think most of the experience lies with the big cement makers, and they keep buying this system for their plants in order to feed their optimizers with this. But a few case studies have been done specifically on raw mill and on downcomer.
Okay, excellent, thank you. Now, what sort of time frame would be required for the installation of these kinds of measurement systems, and would installation impact production in any way?
One of the big advantages of this system is that it is not very intrusive. You have two antennae that you have to put into the process. So you weld on adapter flanges and you put the antennas in. The antennas have a distance of about 350 millimeters. So it's a very small location. You have to create a process connection and then put the antennas in, and that's pretty much it. Now, if the plant is running and you have a pipe or a duct that carries, for example, 1,000 degrees Celsius hot tertiary air, of course you have to wait for a plant shutdown in order to install these adapters. But the installation itself is very quick, so even a short shutdown is enough. When you compare, for example, our raw meal or our raw gas measurement on the raw mill with the orifice that they usually put in, the orifice plate, the modification that we have to do is really minimal. So we have never had a plant complain about the amount of work to be done to integrate our system. It's usually the process connection, a small power supply, which can be anything between 65 and 230 volts or 24 volt DC, and then a 4 to 20 milliamp signal to the DCS or to the plant control system. And that's pretty much it. So it's fairly straightforward.
Okay, excellent. And can you give me a rough idea of the cost of a typical installation process?
Yes, the cost would be along what I described as the scope. So you have a little bit of welding to do to you drill the holes into the duct. If you have refractory lining in the duct, you of course have to take care of that as well. But most of the ducts don't have that. So you drill a hole, you weld on the flange. You have a small fitting where you put the box in, you pull a few cables. How much is that? A few €1,000 maybe with everything. So really minor for a plant. I think not a big thing.
Okay, excellent. Now, your article mentioned that gas flow measurement has typically been and I quote, neglected or even widely ignored process parameter in cement manufacture. Do you see this changing over the coming years as cement manufacturers face increasing pressure to improve efficiency and reduce emissions?
That's a very nice question. First of all, I must say, generally, in many industries, it's a neglected factor. It's also a neglected factor in the power industry, in the glass industry, and mainly because it's so hard to measure. People think measuring hot gas flow is easy, especially in large ducts. It is extremely challenging and difficult if you want to get to a certain accuracy level that is good enough to control your process. So many experts in many industries have worked decades basically to work around a non-existing airflow measurement. So there's a lot of parameters taken and a lot of calculations made to estimate the airflow because you can't measure it. And I actually have a very nice story about this. When I first approached Holcim with our technology 20 years ago in Holderbank, they invited me to their technical center, and there was a wonderful and excellent discussion of many experts. And they were very excited about the fact that they can measure gas flow. But while I was explaining this, there was a discussion developing between the innovators and between the more, let's say, conservative experts. And they were saying, oh, but if we have the kiln head pressure and we have this pressure and we know this and this and this, we can calculate all that. We don't need it. And it was a lengthy discussion. And I went out and I thought, man, this is really surprising that it's obviously a big there are big differences in opinion of what to do. Now, to come back to Holcim, over the past 20 years, Holcim has become a monster client of our company. Many plants of Holcim around the world are going for this measurement. So what is the essence of this? You have experts, one on the innovation side, one on the more conservative side to make sure everything is working right. And within the companies, within these organizations, it takes time to adapt to the fact that you have this sort of measurement now available. And over time, it's become more and more popular amongst many cement producers, and Holcim being one of our real key clients, and we're very, very happy to work with them.
Okay, and on that note, I think that brings our spotlight session today to a close. So on behalf of the World Cement team, I'd like to thank you, Hans, for joining us today and exploring some of the details around these advanced measurement systems. And of course, if you in the audience haven't yet read the article that we've been discussing today, simply check out the January 2021 issue of World Cement in print, or head over to the link appearing on your screen now. Thank you again, everyone. I look forward to seeing you all at the next World Cement Spotlight.